All right, what's up, everybody? Hey, what's up, Andrew? Nice to see you. Um, yeah, sweet. We're gonna wait for people to kind of roll in. I'm gonna we're gonna do like we have been this week. We're gonna look a little bit more at this device. I fixed the issue from last stream of my firmware reader getting messed up. So we'll talk about that, and we will also, just take more Q&A. But now we can actually look at the firmware. We actually have a way to get like the real firmware off of it, not the corrupted firmware read. So yeah, that'll be cool. All right. Sweet. Where did I get the shirt? I actually got this given to me by my colleague who went to recon up in Canada, and I think like the IdaPro people were there, and so that was yeah, got me some swag, which was very very nice of them. Okay. Yeah, I gotta like put chat somewhere where it's more accessible. Okay, there we go. Hello from Italy. What's up? Cool to have people from all over the world here. All right. Do you believe in self-taught than college education? So yeah, I actually talked about this last time. I come deeply from the academic, like I have my master's degree, so I have all of that experience all in that direction. But that being said, I do think the way the current job market is, and just like the tech industry in general, there are a lot of career paths where you don't need that. I'll say it that way. Either way, you are going to need I don't know, just focus and direction to achieve your goals. So I feel like your mindset is more important than whether you do a traditional education or you get self-taught and all this stuff. So yeah. Hello from Norway. Awesome. We got people from Italy, Norway. This is pretty sweet. Hey Matt, what if I found a bug in an IoT device? Should I approach the company? That depends on what your goals are, what company it is. There's a whole bunch of things. There's a whole bunch of variables there, right? It's like if your goal is to publish your findings, then you may want to disclose it to the company first. That's it's kind of dealer's choice, right? If they have a bug bounty program, then obviously you want to submit that bug through the proper channels in order to be eligible for the bug bounty. But you can also just go for it and just release it to the public. People don't do that as much, but it depends on the finding. Depends on how bad it is. That's my 2 cents. Sweet. Sweden, Turkey, Germany, India. I like it. From all over. Cal says, I extracted firmware off a router and there is only LZMA compression files. Okay, that is like the number one like false positive inside of Binwalk. It's probably not it's not like a false positive, but it's like not the thing that you're actually looking for when it says like, I found like an LZMA compressed like file or section or whatever. Things like, SquashFS or the other file systems types will potentially use LZMA compression. And so really it's those other items. So if you're only seeing LZMA, then or zlib, same thing. Those are just compression libraries that are oftentimes used by other embedded file systems. Yeah. So my guidance for that is it depends. And gosh, this is where it's always helpful to have some kind of like UART output of the boot up process, because you might get hints about what type of file system is on the device. You oftentimes can get like offset data. So not to like not to like massively self-promote here, but I showed that recently. Oh, did I? Is that in my blog post? Hang on. Okay, we're gonna go, because I just dropped a blog post today. Again, you know, selfless promotion here, where I talked about carving file systems out here. So, okay, so here you can like cat proc mtd, but it sounds like you are not in the situation where you are able to do something like this. So, that being said, oftentimes in the UART output, you will get some equivalent of this that shows you like the different partitions. Oh, do I not have it for this device in here? I don't. Let me show you an example. Let me go. Nope, that's my Windows RDP box. Okay, we're gonna go try to find the UART output for the UniView camera that I have here. Oh, is it even here? It's not here, man. Darn. Okay, well, yeah, I think I've talked about this before, but basically, like in the typical Linux boot up process, it will show you like potentially like a partition table, and then oftentimes you can carve files out that way, or like you can carve partitions out with DD using that offset information. I don't have it recorded here, so but that's where I would go if I would, if you do have a live device that you have some kind of console output on. That's kind of would be my next approach in that situation. Have I heard about the Emba software package? Yeah, the whole like Emba. I mean, it's kind of like a toolkit. It's this massive project. I've used it a couple times. I definitely need to get it like set up. My one piece of feedback is that it doesn't seem super simple to deploy and get set up. So if I'm being honest, I've kind of like stopped at certain points. I don't know if it's like installed by default on Kali or if you do have to just deploy it in Docker. Either way, yeah. So so Emba, it's a very cool, very cool project, but I've used it a couple times. Yeah. Very cool, very cool. I think it made me realize reverse engineering and embedded systems are really cool. Well, that's awesome. That's what I want to do on this channel. It's a passion of mine. Obviously, for me, it's a passion and a career. So I like doing it in my free time, and I think you can choose either one of those paths or both of them. But yeah, I think it's fun. Reverse engineering specifically, I think I told people on last stream, people asked me, like, what was the most surprising thing I've ever found? I kind of converted that question, because that's like, surprising is hard to define, but I kind of converted that question into like, what is my favorite video? And some of my favorite videos of mine, not necessarily the ones that get the most views, are like reversing, like custom encryption and stuff like that. Just like getting inside the head of like the developer is fun. So let me sorry, I need a way. This is so dumb. I need a way to make my chat larger, but then this other screen looks bigger. Okay, whatever. Dude, Andrew, thanks for the super, by the way. And yeah, I did kind of fly past the 10,000 subs way up there. And yeah, it's been a wild ride. So just riding the wave. All right, I'm gonna keep going through these. These are good questions. I found that the cheapest way to have a school-esque regiment is doing foundational theory certs. Yeah, yeah, no, that's what I'm saying. I think all forms of like alternative education, right? Whether it's self-taught on YouTube, certifications and stuff like that. man, in the next like couple decades, I think we're going to see a massive disruption or reorganization of higher education in the United States. Um, either prices have to come down of higher ed, or like they have to compete in some other way with all of the other resources that we have now, right? Yeah, absolutely. Sweet. Where's the operations manager for Europe's biggest hydropower plant? Sweet. Doing some OT stuff. Have I worked with anything OT? So, funny enough, we're talking about education. So, during my master's degree, I actually did some study and some research in a SCADA security lab. It was, dealing with Siemens equipment that was used in kind of the bulk transmission, power transmission delivery systems. And so I've got a little bit of that background, but have since like moved into other areas. But sometimes I interact with devices that kind of straddle that line between like IT and OT that are more like commercial security products, enterprise grade systems. I'll get to touch some real like OT stuff, but it's always fun. Yeah, big impact, obviously. And okay, the cool thing about the interesting thing about OT is that kind of the traditional like CIA confidentiality, integrity, availability model, right? It's always that interesting use case where all of a sudden, like, where in most security assessments, like an effect to availability would be like, whatever, what are you gonna do? But in OT, that's like the most important, is like the system has to be online. The medical device needs to stay online. The power needs to stay online, right? So that's what I like about OT, is it's kind of a not traditional cybersecurity risk analysis that's going on there. Sweet. Cheers from Russia. Peace, man. What's up? Oh gosh. You also seem to have a pretty bare bones Vim setup. Why do you use Vim over NeoVim? That's just what I use. I like, I'm really actually behind in terms of like adopting technology. I didn't get like a smartphone till I was in my master's program in college. I don't know. I'm just like, you might look at me here and be like, oh yeah, he's probably like, has all the latest, using all the latest tools. Like, no, I just kind of use what works and what I'm used to. I'm already an old curmudgeon, so yeah. All right. Hello, Matt. You do this for work, right? How do you break into it? I just finished my master's in cyber, have some certs, most jobs want to see proven work. Yeah, chicken and egg problem, right? How do you get experience? So, okay, yeah, there's, especially if I assume like you do this for work, meaning the offensive cyber side of things. We've had a great discussion in our Discord community, which somebody should drop a link to if somebody wants to. But there's been a really good active discussion in kind of our careers or like jobs channels about the industry in like, especially offensive cyber, and specifically in like hardware hacking, right? And one of the things that is hard is that it is the opinion of some people, and I do lean in this direction, that hardware offensive security is not a entry-level position. So my first jobs were more general offensive security, but I kind of got my foot in the door at a good place. I would say other really good starting places is some kind of a DevOps team with a security angle, or a like system administration, network engineering. All of these things are going to help you. Now, you're going to want to, in your free time, kind of self-study. And then I will share my career journey in that I quasi-social engineered myself into the role that I wanted. Now, what do I mean by that? So there are lots of companies out there that make IoT devices, OT devices, like embedded systems, right? And they might not currently have any in-house offensive cyber roles. They might have like a red team for their IT systems, but not for their devices, right? And so if you want to be that person at a company, you might go take like a blue team role, a defensive role at that company, and then, in your free time, like so step one, like, infiltrate the company. And like by infiltrate, I mean like go do a really good job at the thing that job description is. And then when the opportunity presents itself in your free time, be like, hey, can I just go like do a test of that device? And they'll be like, sure, you're already crushing it at your main job. Why not? And so that is a potential way to pivot yourself into and to design your own like job and career if you will. So based on my experience, the real hardware hacking is 10% of soldering, attaching wires, and 90% is reading the documentation. That is so true. That is so true. Yeah. And sometimes this maybe even comes across in my videos. Obviously, like I do videos that are heavy on the stuff over at the workbench because that's what people like to watch, right? But oftentimes, in terms of like timeshare, so it's kind of funny because I have this desk that's in front of me right here with all my computers on it, and I got my hardware desk. It's like I spend, maybe like 5 to 10% of my time over here, and 90% of my time right here at my desk, like looking at software, reverse, like once I dump the firmware, like we're gonna do today. I did. Oh, by the way, I fixed the firmware dump from last stream yesterday, so we'll look at that in a minute. But I do spend most of my time at this desk, like analyzing software that I've pulled off of a piece of hardware, or writing software to attack the hardware sitting over at the hardware desk. I keep it separated just to keep my head straight like that. But you are right. The cool parts of the job, like any job, it's like not as glamorous as it looks sometimes. Sweet. It would be great if you plan videos about emulating or debugging one of the binaries from the UniView camera. Yeah, that's a good idea. Yeah, there's that like one big binary. I think it's called like Firmware server or something like that. That'd be a good idea. Yeah, to do more like binary stuff. I do want to get more into some binary exploitation, and if I do streams in the future, like honestly, like that's something that I'm kind of a novice in, so it'd be fun to just learn and let people watch. That's cool. All right, I'm going to take a couple more questions, and then we're going to jump over, and I'm going to show you how I fixed the firmware, like dumping the firmware on this device. Favorite place to buy old hardware and take apart and hack? I have some good finds at Goodwill. Yeah, I think I've told this. Like Goodwill is usually my go-to place. The place where I live now, it has less Goodwills or like thrift stores around here, but when I was in the city, thrift stores will have all sorts of like Wi-Fi routers and stuff like that. Funny enough, there's a discussion going on in our Discord channel about the legality of reverse engineering routers or modems that are owned by your ISP. Funny enough, I've found those devices that have been given away to Goodwill before, like sitting on the Goodwill shelf, which is kind of funny. Yeah, sweet. All right. I'm just gonna try to find one more question, and then we're gonna jump over. Have you ever? I'm gonna assume that's a typo. Am I a man in the middle? Communications between components on the board. I have done that a couple times. Unfortunately, those were for client projects, so I can't demonstrate those here. And so, but oftentimes when I have done stuff like that, like getting in the middle of communications, it's been a situation where maybe there's like some like Linux CPU, and maybe there's like another microcontroller component on a board, and they talk to each other. That's really common, right? on a lot of these more complex embedded systems. Where oftentimes you'll have like a microcontroller that controls more of the thing that the device is meant to do. That's as much as I'll say. And then the software is all running on like the Linux side on the bigger CPU. And then there'll be a communication channel between those two chips, and it'll be like UART. It'll be a serial communication between them. And yeah, there's some cool stuff you can do if you can like physically man in the middle those communications. So yeah, it's fun stuff. All right, let's get a little bit into the firmware dump, and I'm going to show the progress we made. Actually, I didn't have to change this at all. This was good, but we will take a look at it on the workbench. To get everyone up to speed, if this is the first stream you're joining, this week we are taking a look at this Dahua camera. Now, you guys corrected me last time, and I was like, no, but it says, I was calling it the Alhua camera. I thought that this said ALHUA, and oh gosh, so my camera is not focusing on the right thing. There you go. But it turns out that's like a D with an A inside of it. This is the dumbest logo I've ever seen, and I think you should feel bad, because I look at that and it's clearly like an A and then an LHUA. But apparently I do not know how to read. So we have the Dahua camera here, and last time we took the firmware chip off of this spot right here. Let's zoom in. So you can see that we have a 8-pin chip that is missing over here. And then we talked about how I have this incredibly sketchy setup because I do not have the correct reader for this. And so I actually have this chip in here upside down. And so then I have these wires to rig it up to my reader in the correct way. Well, that leads to some problems when we try to read it over here. Let's plug it back in. All right. Yeah, the A is like inside of the D. It's yeah, I don't know. It's a fancy logo. I'm clearly not in logo design or marketing, so what do I know? All right, let's show you guys my sketchy Windows RDP laptop that's sitting over there on the desk. And so last time we searched for our device here, and we know it's a WSON8. And so last time I said, okay, we're picking this profile, and you can see that the main difference is that they're both the profile for the WSON8. That's the package. That's the physical dimensions, the physical layout of the chip. So if you're kind of new to this, oftentimes the manufacturers will make the same chip on the inside of the flash chip, but it will have a different physical characteristics, a physical package that's put into. And so ours is this WSON8, but you can see there's these two profiles that are WSON8. This one has, in parentheses, it says X4, and we'll explain what that means. And then this one says X1 ISP. So if I go, let me just go to the 4X1 that we selected last time. So last time we read it with this profile, and it failed. It had a bunch of bad reads, and then when we transferred the firmware file over to, excuse me, our system, it was just a bunch of junk. It was obviously just a very bad firmware read. So if we look here at this chip's description, we will see, okay, so it's an 8-pin chip, and then here is the pinout for this chip. So you will see that there are 4 I/O lines. So there's I/O 0, 1, 2, and 3. And so those represent, that's what the 4X or the X4 means on this profile. It means that it's going to use all 4 of those data lanes to communicate with the chip, which obviously makes it go faster. But we were getting errors, and part of the reason why we're getting errors is because there's all that wire in between the reader and the chip, and that's just not good for things. But if we go over here and we select the 1x profile here, this is designed for in-circuit programming where you're like probing the chip when it's on the device, and so it's kind of designed to be a little bit more resilient to errors, and it goes slower. But device programmer is unavailable. What are you talking about? Oh, it's not turned on. All right, let's go back here. So now we can click read, and it reads just fine. It takes a little bit of time, but it does read. And I was able to, we're just not gonna wait around for that. But hang on, we got a question. If you had a bad read and flashed it back on the device, how did you get the original firmware back? Oh, that's a good question. So all I'm doing is reading firmware. I have not written anything to the flash chip. So by bad read, I mean that like I read it, I got a bunch of junk. I read it again, I got a bunch of junk, and then I changed my settings to these ones that I have right here, and I read it and I got a good read. I haven't written anything back to the chip yet. Yeah, and that's a good thing to understand, that before I ever do a firmware write, especially, usually I do this even when I'm reading, just as a check, I will read the firmware, and I know these tools have a built-in check where it will try to verify if the read was good, but I don't trust that. So I will do a full read, and then it'll do the internal like verify step, and then I will save that to the file system, and then I will do a whole nother read cycle, and then I'll hash those two files and make sure that they match. So that's just me being paranoid. But okay, so yeah, we transferred this to my computer over here, and oh yes, I was going to show some settings. So, gosh, stupid RDP. So I'm going to show you some settings in here that are important for you to understand if you're trying to extract file systems and if you're trying to do firmware modification. And this is really tricky to do firmware modification on, so we're not going to get into that today. But here we can see that there's a bunch of parameters, because this is a NAND flash chip, and one of the things here is this section that says the spare area in the file. And so you can either include the spare area or you can not include it in the firmware dump. So what is the spare area? So over here, we will see that in the description of the chip, and this is really small, I can't make this text bigger, sorry guys. We can see that the block size on this chip that's defined in the profile over here in our firmware reading software, it says that the block size is 128 KB, and then there is a 4 KB, like it says plus 4 KB. So what does that mean? So that is the spare area, which is often used for, you know, error correction algorithms and stuff like that. And so there's this extra space, right, that is available on the system, and that the main firmware doesn't go in that spare area. Now, sometimes there are things like JFFS2, which will actually use the spare area to do certain things for the main file system. But for the most part, if you want to do firmware extraction, if you want to like extract a file system and just look at it, then you're much better off having like a none here for the spare area include. And what I actually do is I always just do both. And so I did that, and now I have both files here. So let's make this a little bigger. And it's really funny that like my OBS is all jacked up over here. Hang on. Oh well, I just don't have a great preview, but that's fine. We're just gonna make sure that the live stream's going fine. Sweet. Okay, so like I said, over here I dumped both of these, and so we can actually look at the size of those files, and we can see the difference, right? So there is that 128 megabytes, which lines up with this, right? It says the device size is 128 megabytes plus 4,000 kilobytes, right? So that is the extra space. And so we can see the difference in the file sizes here, right? So that when you have the spare area, it's 1, 2, 3, 4 megabytes more than when you don't have the spare area. So when we're using binwalk to do extractions out of here, let me delete all of my extractions there. And let's show you what happened. So the first time I did it, I wasn't thinking about all of this. And I simply went over here and tried to do the extraction here. And it comes back with a bunch of errors and it can't like parse things correctly. I'm just going to stop that. Let's get rid of that. But yeah, you can see like it caught it, like nothing was going right. But then I was like, oh yeah, I forgot to dump it without the spare area. So let's do it now with the no spare file. And we should get a bunch of good extractions there. So now we can go into here and let's just look at what files it extracted. So there we go. We're actually getting, file systems that have been unpacked inside of here, which is kind of cool. So, okay, I'm just seeing some of these files for the first time. These look very interesting. Huh, interesting. So, but this is cool because now we have the full file system, right? So like, if we do like find rep for, I don't know, password, we get the Etsy password file, and we get a couple of them here because we have like 2 root file systems. Basically, we have, one at this offset in the firmware file and another one at this offset in the firmware file. And we can go ahead and we can cat that file out, and we can see that there is indeed this root user. There's an admin user that has DSH. Oh, that's interesting. I bet this is my first time, like I barely got this working before I got on stream. So I had a very limited amount of time to go through this firmware. So we're just gonna go through that. And I feel like my chat is jacked up, but maybe not. Yes, the device has 2 root file systems. So that's very common that a device like this, a Linux device like this, its update system will be designed for resilience, right? And so what it'll do typically is it'll have some system where if it does a firmware update, first it will like copy the, it'll have like an A and a B like partitions, and then yeah, there's no shadow file. Yeah, we need to investigate that. But where was I in my thought process? Yeah, there's like an A and a B root file system, and also like an A and a B. There'll be like 2 kernels, 2 root file systems, and then the bootloader will have some kind of configuration that says which one it should boot to by default. And then if it's going to do an upgrade, it will write the upgrade to the one that's not selected. And then it will flip and just point the boot process to that other one. And then if something fails, it can fall back to the other root file system and kernel. And so it's a way to attempt to put some resilience into these devices, especially their OTA update process. So yeah, so shadow, there's like, no. So now the thing is that on a lot of these systems, like if they have like a database somewhere where like the password is like stored, then what it will do is it will like on boot generate the shadow file. That's what I found on a lot of these devices, and it's just kind of like some custom thing that different people do. So then usually what I would do is I would need, let's just like grep through all of this for like shadow and see like, is there anything that would call, I guess like we could just look for like Etsy shadow. Okay, SSHD. It's like only those things match it. Yeah. Like, what the heck? But data. Data partitions. Sometimes there'll be multiple data partitions, but yeah, that kind of depends. Okay, that DSH, that is really interesting because I wonder if they do allow you to SSH the device. I have not yet booted this device up and actually just tried to interact with it in a normal way. So I am interested. Okay, let's find DSH. Okay, there's the DSH binary. Let's just like look through the strings there. Because DSH, it might be Dahua shell. It might be some custom shell of theirs. Or it could totally be like another common shell. But I'm wondering. Yeah. This is their lockdown shell. Yeah, this is the admin user. Okay, this makes sense, right? So just like on the Uniview camera that I just did like a video and blog post about, right? Where I was able to bypass, there I had UART access and bootloader access, right? But if you can get in, but like if you normally boot up the device, you can get a shell, but it's this like limited shell where they only let you run certain commands here. And I'm almost, yeah, look at this. Yeah, support commands. This is a custom shell that they have written. Please scan QR code. Challenge. Hang up. You have so many chances left. Yeah, so this is clearly their like custom shell thing. I'm just looking at it. So yeah, we would have to do some reversing on this to see if there's any like escaping we could do. Okay. So you hope we get a hash this stream. There is one, but I honestly don't even know what the heck this hash would be. So let me, so this is a tool I have not yet released yet. I might someday, but let's just run it on this directory and see what it finds. So, okay, so there's this like hash here. It's not that advanced, guys. It's just a bunch of regex. But it does have this hash, which if somebody wants to try to crack that on stream. Now, the interesting thing about that hash is let's like go look at the strings. It's in the SSHD binary, which is really weird. Like this is obviously just, I forgot to do less. Is this like open SSH, right? Yeah, like this is clearly just like open SSH. But if I like search for this, oh, that's not, copy that. All right, if we go search, I gotta escape that. We look for that. What? Hash 2. What the heck? All right, let's look at that again. Okay, so it totally said the file right here. I mean, there it is. Okay, yeah, see, like, so these are like the adjacent strings. I don't know. This is like the first thing I do to analyze a binary. See, so it looks like this could be like a hard-coded password hash, like that's embedded into the SSH binary. But I don't know if this is like a common thing, like, oh, well, okay, like where is SSHD? Let me look at like my SSHD binary. Like, does it have a similar password. Actually, let's compare. Let's do like a string compare to like what's before it. No user, I don't know, like user bin sshd. Like this is on my computer, obviously. Okay, that pattern is not there. There's no like, I don't know. Yeah, like why would there actually be a hard coded hash? Yeah, throwing it at RockU, nice. Yeah, I think 2A, I think $2A is like bcrypt or it's like blowfish or something like that, right? Yeah, it's not like we're gonna be able to like crack this quickly. But I think they like hacked the OpenSSH to like add in some like backdoor account or something like that. Like backdoor, like I say backdoor. It could be like just like a default password or something like that that fires under certain circumstances. But that's fun. Yeah. So yeah, this tool, all it does is it just like regexes through recursively through the file system for certain stuff. So yeah, I mean, there's definitely like a private key in here, which is, I mean, I guess and it's encrypted, so I would need to like figure out like, yeah, so there's like this encrypted private key in here, so I would need to figure out what is loading it or decrypting it. Okay. What refers to it? Okay, that's the raw thing. Okay, this I keep seeing references to this Sonia. Robin is correct. It's in the open. Oh, it's in their source code, really? Okay. That's the password embedded. Oh, okay. Oh, that's so interesting. So, okay, to prevent the timing attack. Fun. Okay, I learned something today. Nice. Okay, so we see reference to priv key in this Sonia binary. I see a lot of references to this. I'm guessing this is like where a bunch of their like custom business logic is like all wrapped into this program right here. Yeah, we see it there. All right, let's go like just like look at this thing here. Yeah. Home Jake and Jenkins. Here's their build, the path to their build system. Starting video daemon. Okay, yeah. So this is going to be probably responsible for video streaming. I'm guessing it's probably also responsible for like whatever web server is going on here. Yep. Video server. Okay. Fun. Okay. Priv key. Okay, so it's loading our private key here. That's fun. Huh. All right, hang on. I'm gonna open something over here. All right, let's copy this. Sure. Bins. All right, let's. Here we go. Yeah. This is obviously just like the SSL private key for the web. Okay, I say obviously, but Saul, you're most likely correct. Yeah. Um, you're most likely right that that's all it's used for. So, um, but we will take a look. Matt, what are you using to see all this? I'm just running strings. So right now, literally at first, well, now I'm in IDA, but over here, all I'm doing is piping the output of strings on some binary into less. And then I'm just hitting page down to scroll through stuff. This is honestly like how I try to like do my first like scatterbrained look through file systems and stuff like that. So, no, I mean, this is IDA. So what? Where is it? There we go. Okay, which I'll be honest, I'm not like a full blown expert on. Oh, is it still analyzing? Dang. Okay. Yeah, this is a massive binary. Um, how big? Yeah, this is like some 14 meg binary. Yeah, so dynamically linked, UC libc. All right, Grant. Yeah, so theoretically, yes, you could decrypt traffic if it was using they. I mean, usually it's like on a local network, right? So, um, so if there's like, if you're on a local network with the gosh, I'm brain farting here. If like the attacker's on the local network and then the like admin was like logging into the camera, then you could conduct a man-in-the-middle attack if you knew the private key. You could decrypt the traffic if you knew the private key and they were not using perfect forward secrecy, right? So there are some TLS algorithms, the older ones, that you can do that to, but all of the newer ciphers, you are forced to do a man-in-the-middle attack. Otherwise, it does like a Diffie-Hellman style like key exchange, where even if you have the private key, you can't recover the session key for TLS. Check in. Oh, okay. Check the bin directory. All right, we can do that. Here, let's just go into one of the root file systems. Just kind of like assuming that they're virtually the same. You want to go in bin. Okay. So yeah, there's that DSH and then BusyBox, which like the standard shell, I'm sure just links to this, like ash, right? Like these are all just links to BusyBox. But this shell is obviously that restricted shell. We can actually decompile that too. Hashcat. So it turns out that like password hash is kind of a red flag. Is not a red flag. It's red herring. The proof key looks promising. Yeah, I mean, we might. Yeah, so that proof key is encrypted, right? So what we need to do, where was that? Where did? Yeah. Where is the proof key? There it is. Right. So we kept that out. It is encrypted, right? So we need to find the like the passphrase or whatever it was that encrypted this. And so I'm guessing that's more or less hard coded into this binary, which is why I'm curious at looking at this. Let's go view, open subviews, strings. And let's search for priv key. All right, here is some stuff. Okay, here's this string. Let's look at some of these other strings. There's interesting. AES decrypt proc. Interesting. Sometimes you can just like find the key by looking at like the adjacent strings here. All right, encrypt, blah, blah, blah. All right, but let's go back to this file. Oh gosh, where is it? This is interesting. All right, yeah, let's go ahead and look at this and say list cross references to. So here is a function that calls it a bunch of times. So let's decompile that. And let's see. Never embed secrets. Yeah, you shouldn't embed secrets. All right. Use the key 1, 2, 3, 4. I don't know. Cert manager. All right. I want to see if there's like any kind of function call like that's saying like decrypt the cert. All right, hang on. Let me go back to the strings again. Privkey.m. Weird. Yeah, I think userbin SSL is actually where. What the? Okay. Vector strings. Huh. All right, this might be a rabbit hole for another time. Oh my gosh, why did I? You guys have been looking at like the view that I never use, the double one. That's funny. Here, okay. Does this have cross references? It does. Okay, what's it being used for? Well, thank you. Okay, well, who calls? Load file root cert. Eh. So was their intern. The intern that did all the work, right? Gosh, why do I? Oh my gosh, that's so funny. There's a the reason why I keep changing my view in over here is that F5 is like the keybind for decompile over here over here in IDA, and it also it's I also use that keybind to change to that other weird view over here in OBS. So I was like how did I hit that? That's why. All right, let's keep looking through the file system. I'm getting too down that rabbit hole there. So yeah, the Sonia binary is interesting. Oh, I know what I want to do. I want to. Yes, I do need. Yeah, I do need one of those Stream Decks. Yeah, it like would actually help me with this. I want to. Okay, actually, because I'm actually like almost more curious in this thing right here. So let's copy this because I think this is their like limited shell. No, go back a couple more. No. Bins. There we go. Okay. Load. Sweet. Bins. This one. Yes. Yo. Okay, hang on. we're going to unmap that key binding in OBS. There we go. Now I can hit F5. Quick summary for those who are joining now. Yes, thank you, thank you. So, summary is that if you were here from the last stream, I had problems dumping the firmware on our device. That is this Dahua security camera. We fixed that issue. We've dumped the firmware, and now we are looking at it. If my voice is low, there's like a bunch of other people that think that it is way too high. So. I don't know how to fix this problem for everybody at the same time. But we extracted the firmware, and we're looking through the firmware image right now that we have dumped using our firmware reader. So that's where we are right now. And we've noted that there is okay. So just a review for myself also that in the password file there's this interesting kind of shell that's given to the admin user. So I'm assuming that on this camera that you can actually SSH into this device, SSH or Telnet or whatever. I haven't even booted up. I haven't even like actually used this camera properly yet. So, but you'll notice that binsh, like just the standard normal shell that gives you access to everything, is given to the root user, but the admin user here is given the bin dsh shell. And we were like, okay, is that a common shell out there or is it a custom one? It's obviously a custom one because there's a bunch of strings in there that just kind of give it away. But we have now loaded that into Ghidra and we're going to take a look at it. So again, I'm going to go to view. Let's just go look at some strings. View, opens up view, strings. All right. So it kind of gives itself away here in that some of the first strings here we can see, okay, so there's a route-n command that apparently is supported, but yeah, so not support, try help. So, or support commands. There's probably a list here somewhere of the commands that it actually does like allow, and ooh, this is okay. So this is interesting. There's clearly some kind of like process, I'm guessing, that Shift F12 for strings. Got it. I'm not an IDA pro by any means. So I'm guessing there's a way to get it to drop you to a full shell if you have their approval via like some QR code or like admin access. So yeah, like this is really interesting. Let's go to like one of the first commands here or something. And just, yeah, usage. Let's see where this lives. All right, now, okay, cool. That key isn't bound anymore. All right, so, okay, cool. We see a bunch of system calls here to, you know, our cat and proc, interrupts, meminfo, devices, all this stuff. We're running the route command, okay. If v4 equals -1, not support, try help. Interesting. All right, I want to go back actually to like, wait, is this? All right, let's go back to strings. I mean, yeah, like some kind of command injection or a way to escape. Yeah, command injection that would allow you to escape the shell would be a pretty interesting finding, right? That's what we need to look for. There's got to be like a way. Hang up. So interesting. There's clearly some kind of like authentication thing that it can do. Get command. That looks like a fun function. Or something. Where is it called? Okay, it's all this same thing here. Decompile. Hmm. Interesting. Okay, it's clearly got all the stuff for that like authentication thing. Huh. Is that all that there is in here? Am I looking for something specific? Not at all. Not at all. I'm just curious how this like this shell works. All right, let's see if we can go like exec. Let's see if there's any like exec calls here. Yeah, I know it's like an external function, but how do I like, here we go. List cross references. Okay, does anyone call this? All right, that looks safe, unfortunately, but let me look. Maybe search for references. Yeah, so right here, it's saying, okay, it's like checking which shell to use almost. Okay, this is, oh, this is such a, okay, this function is important. Yeah, like, look at this. It's, yeah, please try later. Domain accounts. Please scan QR code. Yeah, so there's clearly some mechanism to kind of like sign like scan your QR code and it like sends something to maybe to the cloud or you have to get it signed out of band, right? Like like the response. You have to like give your response. Yeah, actually, yeah, yeah, that's a good point. We should go back out and look at the init scripts. Okay, this is really interesting. There's like some kind of command here. Yeah. This, like, if we can get input into this, that seems bad. Yeah. I know. Like, so if we can, F5 is the only key. All right, so if we can control any of this, we, yeah, we win, right? All right. What? 34. Okay, it was v23 string length. Yeah. All right. You think this is to add it to the NVR? Oh, yeah. It might be used for that, but I feel like this is a shell. So this program, the thing we do know about this program, guys, is this like is the shell that gets handed to the admin user. So yeah, you're right. No, like this. Okay, what's this? What's this sub? Return D word. Okay, so something writes to that. All right. No. Where? I went too far back. Whoops. Go back here. My bad. Where did we go? Up here somewhere. Here it is. Which might have a signature check. Yeah, I get that. But like if we in any way can get our input into this, then but yeah, it might not be doing that. Uh-oh. Hey, I'm back. How we doing? I think Linux decided to kill Chromium, which was fun. Yeah, am I back, everybody? Can I get a? Oh, you didn't notice a drop. Oh, weird. Okay. Like, they didn't completely close out, but like Chromium kind of crapped the bed for me there. Yeah, this is interesting. Let's do what you guys suggested with like maybe the last few minutes here. I think you guys had a good idea. Oh, he didn't see a drop. Okay, sweet. Let's go to, let's see, init d. Okay, this is helpful. All right, let's look at all these. Get boot info, fun, hardware ID. All right, so here's some cool stuff. Partitions. All right, I just have to know. I'm like, what is this? What do we got? Replace commas with spaces. Okay. Get hardware ID. Okay. That's interesting. There's some kind of like, yeah, it's clearly, I'm not, the hardware ID might be the MAC address, right? But it might not be. Interesting. Oh yeah, it's like if all else fails, it falls back to that. All right, and it's like kind of interesting, but let's go. This mount script. yeah. No, the comments are always great on devices like this. Okay, this is nice. This is telling us like how it's like setting up the UBI file systems. All right. Cool. Anything in here interesting? Okay. It's dnode. All right. Interesting. All right, I'm gonna go see if that like what the partitions that are not the two root file systems have for us. Well, there goes my dog. All right. Come here. Come here. It's okay. Say hi. Say hi to the internet. It's okay. You have Telnet D being run. Oh, really? All right. Buddy. So there's like Telnet here. Oh. Whoa. If user data image flag. Okay. That's nice. So we just have to like drop that file in there somehow. Yeah, it's a golden doodle. What the heck? What is this image flag file? Search strings for VIP. Why? What's that? I'm a big word. Oh, okay. All right. I don't know if that's anything. Okay, I wanna search for this thing That is really interesting to me. Okay, it's only in there. Oh, no, 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 no. It's in Sonia too. Okay, what is this image flag? What the heck is that? All right, back to Sonia here. Strings. Okay, there's a string. Crossrefs. Here we go. IMG mode. Okay, is that like... I mean, it's clearly some like debug mode, right? So, oh wow. IMG mode. That is definitely something to look into. And obviously, like, I'm gonna get this like thing soldered back onto here, and next video we're gonna actually like look at the live device and use some of the knowledge that we have of the firmware to try to mess around with things. But you also have a script that adds users in RCS. Oh, okay. Good catch. Where'd we go? Is that it? No, that's definitely not it. Come on. Where is it? There it is. That adds users, like, do like user add, or is it like just adding it manually? Yeah, the QR code. Yeah, that QR code is super interesting. You said you found. Oh, user file. Oh, interesting. User.sh. Where is that? There it is. Huh. This looks like it's just like some kind of yeah, like configuration settings, like user user customization stuff. T2Y0 S0 is your serial port. So yeah. So we never got serial. What I do need to do is go back and probe on the chip itself. I don't have a pinout for the chip. I can't get a data sheet for my exact version of this chip. So that's probably a next step for me. And then next video, you also have a script to add. Yeah, okay. Yeah. well, thank you. All right. They set it in the RCS if keyboard isn't present. Maybe. Yeah, we'll have to get this device functioning. I'll get that chip soldered back on next video, and we will do some live interaction with the device and actually like poke around at it and see if we can like get the limit, even like get access to this limited shell and start playing with it. So yeah. How do I connect to tiny chips like that? We use these guys. So these little PC byte probes. That's what I use. So yeah, sweet. Well, thanks guys. I'm probably gonna call this a day. I'm glad we actually got the firmware extracted. You know, obviously messing around with reversing a little bit, but and yeah, thanks for the feedback and ideas in the comments. This is fun. So obviously I'm doing it every day this week because I took some time off work, but might try to make this like a once a week thing. That might be more sustainable long term. But yeah, this is fun. So next time we'll get the chip back on and we'll like probe it over the network, do stuff like that. Sweet. Thanks guys. Bye.